All right, let's go over this review. So I'm going to just start from the beginning and work my way through it, okay? All right, so number one, we're going to write the inverse of each function. So to do this, there's no shortcut for these ones because they're linear. All three of these are linear. Let me adjust this. And so I just need to Freaky Friday. So change f of x to a y. So y equals 3x plus 7. And then switch the x and the y. So x equals 3y plus 7. I would subtract 7 from both sides. Instead of writing that step though, since it'll be a -7 on the left, I'm just going to put x minus 7 equals 3y. So I'm going to skip that step just because I don't have a lot of room. I'm going to divide both sides by 3. I'll show that step. Now you could leave your answer as y equals x minus 7 over 3, or more properly, it would be f inverse of x equals, that's really a 1 in front of that x. It would be a 1/3 x minus 7/3. And that's 1a. Okay. Then 1b, f of x equals 12x minus 6. Change the f of x to a y. Okay. And then Freaky Friday. So x equals 12y minus 6. And then we got to solve for y. We're always solving for y on these. So I would be adding 6 to both sides. So on the left, it would be an x plus 6 equals 12y. And then I need to get rid of that 12 in front of the y by dividing everything by 12. And so then my answer would be f inverse of x equals, that's really a 1 in front of that x. So 1/12 x plus 6 over 12 reduces to 1/2. And there's the next one. Okay, for 1c, same process. We're changing f of x to a y. And then Freaky Friday, I gotta switch x and y's places. So x equals 12y plus 10. And then I'm solving for y, so I gotta subtract 10 from both sides. So on the left, it'll be an x minus 10 is equal to 12y. And then we need to divide both sides by 12, or technically everything by 12. You can write it like this as well. That helps you remember that you gotta separate it. So f inverse of x is gonna equal 1/12 x minus 10 over 12. I could divide out a 2, so it reduces down to 5 over 6. And there's that one. One and done. Okay. Next one, number 2, it says solve algebraically for all values of x if the square root of 11 minus x plus x equals 5. Well, the first step is to isolate the radical. So we got to subtract this x that's outside the radical so we can get it away. All right, I'm going to put my work over here on the left. So we'll have the square root of 11 minus x equals 5 minus x. All right, from there, I need to get the stuff out of the radical. So the only way to do that is to square both sides. Now the other side is a quantity squared. So you have to be very careful when you multiply that out. Students always screw that one up. Well, first of all, when we square a square root, the stuff inside gets to come out. So 11 minus x comes out. 5 minus x quantity squared is 5 minus x times 5 minus x. And you have to distribute that out. Okay. So when we distribute that, we'll have, that's what, 25, negative 5x, another negative 5x, negative x times negative x is positive x squared. Bringing down the 11 minus x. We have to combine like terms. So we have these negative 5x's that we can combine. And then we're also going to put that in standard form. So I'm going to put my next step over here. So I have 11 minus x equals, and then the x squared goes first, you know, standard form, minus 10x, and then that 25 is positive, so plus 25. Okay, so I have that now. All right, anytime you have an x squared, that's your highest degree, you need to get everything over on the same side as it, because you're going to need to either factor or use the quadratic formula to solve it. So I need to get 0 on the left. So I'm going to subtract 11, and I have a like term that it can subtract with. And I need to add x, and that one also has a like term I can add it with. And so I'm going to get 0 equals x squared. Negative 10x plus x is a negative 9x, and 25 minus 11 is 14. And that looks like it's factorable. You could use the quadratic formula if you wanted, though. So 0 equals, I need two numbers that multiply to 14 that add up to negative 9. It's going to be negative 7 and negative 2. Because negative 7 times negative 2 is positive 14. Negative 7 minus 2 adds up to negative 9. So those are my two factors. So I'm going to get two solutions. So we get x equals 7 and we get x equals 2. Here's the thing. We just solved a square root function. So we could get extraneous solutions with square root functions. So we got to check them. So I'll put the check work underneath. You got to plug it in to the original. The original is this function up here. So square root of 11 minus, let's check the 7. So plus x, so another 7. Does that equal 5? Well, 11 minus 7 is 4. The square root of 4 is 2. 2 plus 7 is 9. That does not equal 5. So x equals 7 is extraneous. If we try the x equals 2, I'll have the square root of 11 minus 2 plus 2, and I need to see if that's going to equal 5. Well, 11 minus 2 is 9. The square root of 9 is 3. 3 plus 2 does equal 5. That one works. So x equals 2 is the solution. X equals 7 is a solution, but it's not the solution because it don't work, and that makes it extraneous. Number 3. A function is graphed in the coordinate plane. Write the equation for the function. So this is the sideways parabola. It's the top half. So I know it's a positive square root function. We have to look at its critical point, the starting point that it has, because we're comparing this to its parent function. Remember, the parent function always starts at 0, 0. It also has a point at 1, 1. So this is the parent function. Okay. So we need to see how it changed, how it shifted. Well, this coordinate right here is at 3, 2. That means that the x was shifted to the right 3, and then the y value was shifted up 2. So it went to the right 3 and up 2. Remember, this is a square root function, so when I write its equation, I could put y equals the square root of, to show it went to the right 3, you put x minus 3 under the radical. To show going up 2, you put a plus 2 after the radical. And that's the equation. Number 4. What does the term 1-to-1 mean? 1-to-1 means that the function and its inverse are both functions. That means they both will pass the vertical line test. Which of the following cube roots is not 1-to-1? So to tell when a function is not 1-to-1, first of all, cube roots, most of them are 1-to-1. The ones that are the ones where we can see their shiftings from the parent function. If we can't tell what the shifting is, then most likely it's not 1-to-1. In other words, the way I've been explaining it is if there's extra junk in the trunk being the radical, then it's not 1-to-1. For instance, letter A, we can tell that this is a cube root shifted to the left 4 units. That one is 1-to-1 because it's a shift of the parent function. Letter B has an x squared. What the heck? X squared under the radical? What do we do with that? That's extra junk in the trunk. This one's not 1-to-1. So B is actually the answer. C, I can tell that it went left 4 and up 3. So since I can tell its parent function shiftings, it's 1-to-1. F of x for letter D, that can be rewritten as 1/3 times the cube root of x plus 4. They just put the denominator of that fraction underneath the radical because the numerator is just a 1. You can do that. Even if it were a 2, you could do that. Okay, it's allowed. So it's just, but it's still, that's a vertical shrink, the 1/3. And then the plus 4 is a shift to the left 4. So I'm not going to write that one, but yeah, it's going left 4 and it has a vertical shrink by a factor of 1/3. But that means it's 1-to-1 because it's a shifting of the parent function or a transformation of the parent function. So B is the correct answer because that is the one that is not 1-to-1. It's got extra junk in the trunk. Number 5, simplify and state the restrictions. So we are adding fractions, so we have to get CDs, the common denominators, which means I've got to factor that first denominator. It is a special case, a difference of 2 perfect squares. So we're going to get 6x minus 2, that's its numerator. You don't need to factor the numerator when you're getting a common denominator, not till the end. And then x squared minus 4 factors down to x plus 2x minus 2. Plus, the other fraction, the denominator is just an x plus 2, so there's nothing we can do with that. All right, now we can see what the denominator has. Look at the bigger denominator. The smaller denominator is missing a factor of x minus 2. So that means we need to multiply by x minus 2 top and bottom to make it, oops, that's supposed to be minus, to make it have it. This was supposed to be a minus, by the way. Okay, so I have 6x minus 2, and I'm going to put this all over the common denominator. I know I'm not done writing the numerator yet because we're going to need to distribute here. So first off, 2x times x is a positive 2x squared. 2x times negative 2 is negative 4x. 1 times x is x. And 1 times negative 2 is negative 2. And then we have to combine like terms, and then we'll get the rest of our answer. So let's see, we're gonna have, put equals over here. The only x squared term is that 2x squared. I have a 6x, a negative 4x, and a positive 1x. 6 minus 4 is 2, 2 plus 1 is 3, so that's a plus 3x. And then I have a negative 2 constant and another negative 2 constant. Negative 2 minus 2 is negative 4. All over x plus 2, x minus 2. Now once you get here, you have to check to see if this is factorable. It's a hard trinomial if it is factorable. But we need to check by product sum because something could cancel. So let's try product sum and see what we get. The product is a times c. 2 times negative 4 is negative 8. And it's got to add up to 3. Well, 8 is either 8 times 1 or 4 times 2, and neither one of those options are going to add up to 3. So this is not factorable, so that is my answer. Number 6 says, given the function, determine the equation for its horizontal asymptote. Okay, horizontal asymptotes we find by looking at the degrees. So let's look at the degrees. The degree of the numerator is a 2 because it's x squared. The degree of the denominator is also a 2. They have the same degrees. That means, by definition, that we have to take the ratio of the leading coefficients. Okay, well, what are the coefficients? Well, the numerator's leading coefficient is a 1. The denominator's leading coefficient is a 2. So when we ratio those two numbers, 1 over 2, that means that our HA, our horizontal asymptote, is at y equals 1/2. Letter B. Determine the coordinates of the point of discontinuity. That is a hole. They want the coordinates of the hole. Write your answer in coordinate format. Why did my lock come off? Okay, anyways, so let's find our hole, which means we've got to factor this now. So x squared minus 4, that's a perfect, or a difference of 2 perfect squares, so that's x, oops, that's just x plus 2x minus 2. I don't know what I was thinking. It's that special case. That's not anything, that's a typo. All right, in the denominator, that is a hard trinomial. It is going to factor down to 2 binomial factors. and I just need to do product sum to figure that out. So I'm going to take it to this little space. I'll actually use some space down here. I'll use this space down here. All right, so product sum, I'll do that first. The product is A times C. 2 times 14 is 28, and it's got to add up to 11. Well, 7 times 4 is 28. 7 plus 4 is 11, so these are the droids I'm looking for. When it's a hard trinomial, aka the leading coefficient is bigger than 1, you have to replace the middle term with the new numbers. So 2x squared plus, I need a 7x and a 4x because they add up to 11, plus 14 on the end. Once we get that, we break it in half and factor each side. On the left of the break, the GCF is just an x. And when we divide that out, we get 2x plus 7 left over. Plus, on the right, the only GCF is a 2. And when we divide that out, we have a 2x plus 7 left over. When these are the same, that means you're doing it right. And 2x plus 7 is one of the factors. And the leftovers are x plus 2. So those are my factors of the denominator, 2x plus 7 and an x plus 2. I was going to do the Xbox method on here, but this is going to be a long video already. So if anyone wants to see another method on factoring, come see me for tutoring. Okay. All right, so now that it has been factored, we should be able to see what cancels. And we see that x plus 2's are in common top and bottom. So when we simplify this, we have x minus 2 over 2x plus 7 left. And that means that we're going to have a hole at wherever that makes the x value of that factor 0. So if x is -2, -2 plus 2 is 0. So we have a hole at x equals -2. It's a point of discontinuity. So there's our hole, but that's not what they wanted. They wanted the coordinate. So we have the x value of the hole. We have -2. I need the y value of the hole. To find the y value of the hole, you have to take the hole, -2, and plug it into the simplified version. If you plug it in at the original version or even in factored form before you cancel anything out, it's not going to work because it's going to make the denominator 0. So you have to plug it into simplified form. So I'm replacing the x's with a -2. So -2 minus 2 over 2 times -2 plus 7. And I'm going to get -4 over 2 times -2 is -4. -4 plus 7 is 3. So -4/3 is the y value. And there's my hole. That was 6. Number 7 says the function below has a parent function of y equals 2 over x. Which of the following functions represents the graph based upon the asymptotes? Okay, so what helps is when you identify what the asymptotes are. Okay, so let's see. It looks like we're hugging a wall vertically through here, it looks like. That would be at x equals -1. That's our VA, our vertical asymptote. It also looks like we're hugging a wall horizontally through the number 3. So we have an HA at y equals 3. Okay. So what this means is, remember, the parent function always starts on a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0, the origin pretty much. So this one moved to the left 1 unit and it moved up 3 units. So we need to pick the one that shows that it went up 3 and left 1. This one only goes up 3. That's it. So it's not it because I need it to go left 1 and up 3. This one goes to the right 1. That's what that x minus 1 means, and up 3. So it's got the up 3 part, but it doesn't have the left 1 part, so that's not it. This one, that plus 1, means it is going to the left 1 unit and up 3 units, so C is the answer. D is wrong because it has a negative out front. That means it's a reflection. It is going to the left 1, but this -3 means it's going down 3, so there's a lot wrong with that one. So C was the correct answer. Number 8. It says, what value of x makes the equation true? Now, we're not getting common denominators here. We are trying to solve for x, and x is in the denominator, so that means we want to eliminate the denominator. So when you see an equal sign, eliminate the denominator. When you see adding or subtracting, you need to get common denominators. So we have 2 over x plus 4 equals 6 over, now I'm going to stop because I need to factor that x squared minus 16 so I can see what that denominator has in factored form. And that's a difference of squares, so that's an x plus 4, x minus 4. That's special case. Difference of two perfect squares. All right, you always look at the bigger denominator because this one usually is going to have it all. So if I multiply both sides of the equation by x plus 4, x minus 4, I will get this to cancel, and I'll get an x plus 4 to cancel. So that's what we got to do, because we want to eliminate the denominators. And whatever I do to one side, got to do to the other. Okay, so once I have that, on the left, the x plus 4 is canceled, but I got to make sure to distribute that 2 times the x minus 4, so that'll be 2x minus 8. On the right, these completely cancel. Isn't that fun? And it equals 6. Okay, now I just got to solve. So I got to add 8 to both sides, and I get that 2x is equal to 14. Divide both sides by 2, and I get x is equal to 7. Now on these, the way you check for extraneous is you see if it's a restriction in the denominator, and the only things not allowed in the denominator are a -4 and a +4. So 7's allowed. It's not any of those numbers, so that is a good solution. Number 9, a sum. Which expression is the sum of the series 6 plus 8 plus 10 plus 12 plus ... plus 20? Okay, so we need to tell if it's arithmetic or geometric, and it looks like we're adding 2 each time, and we are. So it's got a common difference of 2. So whatever is in parentheses here with this summation notation is the explicit formula of that arithmetic sequence. And because B doesn't have parentheses, it's not B. It's got to be in parentheses. Okay. All right, so the formula for an explicit arithmetic sequence is a sub n equals a1 plus d times n minus 1. So for this one, I'll plug in the first term. The first term is a 6, so 6 plus the common difference is a 2 times n minus 1. We have to distribute that 2, so we're going to get 6 plus 2n minus 2. Combine like terms, and we're going to get 2n plus 4, or 4 plus 2n. In this case, they use k's, but it doesn't matter. So the 2k plus 4, this one, letter C. That was the correct answer. Make sure you pay attention to details. I could see people picking A because of how close they are. All right, number 10 says the first term in a geometric sequence is 2. So A1 is 2. The common ratio is -3, so R equals -3. It says write the explicit and recursive formula. So for a geometric sequence, the explicit formula is a sub n equals a1 times r to the n minus 1 power. The recursive formula, you have to state what the first term is, it's always some number, and you have to find a term by taking its previous term, a sub n minus 1, and multiplying by what the common ratio is. So these are the two formulas for a geometric sequence, explicit and recursive. Okay, so now we're going to use those for this particular situation. So a sub n equals a1 they gave me is 2 times the r they gave me is -3. Because it's negative, I'm going to put it in parentheses and then to the n minus 1 power. And there is my explicit formula. There's part of it. Now the recursive formula, that is a1, you have to identify the first term, which is a 2. And then a sub n equals a sub n minus 1, the previous term, times the common ratio, which is a -3. And then that is the, let's label it the recursive. There we go. Number 11 says the sum of the first 5 terms. So we're talking sum, first 5 terms. So that tells me that n, the number of terms, is 5, of a geometric sequence is negative 682. So that tells me S sub 5, the sum of the first 5 terms, equals negative 682. The common ratio is 4, so R equals 4. What is the third term? So they want to know A sub 3. What is A sub 3 equal? Okay. Well, this is a geometric finite sum, so we're using a different formula. The formula for that is S sub n equals A1 times 1 minus R to the n all over 1 minus R. Okay? So we're gonna, well, let me bubble this. We're gonna plug in all the things. They gave us the sum, or S sub 5 is basically S sub n. So negative 682 is equal to the first term I do not know. So it's just A1 times 1 minus, the R is a 4 to the 5th power, because that's our n, all over 1 minus R, so 1 minus 4. Okay, and we need to clean that up. So the next step is to do some cleaning. It's negative 682 equals A1 times. Now in parentheses, I'm just going to type that into my calculator. 1 minus 4 to the 5th. Looks like this. Negative 1023. All over 1 minus 4 is negative 3. Now we can multiply that negative 3 to both sides to get rid of it, or we can just do the division right here. Negative 1023 divided by negative 3 is positive 341. So we'll get negative 682 equals A1 times 341. You could just write it as 341 A1. Okay, or maybe even put the dot there so that you can tell the difference between the letter and the number, because things might start looking the same. And then to solve for A1, we have to divide both sides by 341. Negative 682 divided by 341 is negative 2, so my first term is negative 2. But it wanted the third term. So let's find the second term by taking the first term and multiplying by the common ratio of 4. Negative 2 times 4 is a negative 8, so the second term is negative 8. So then when we find the third term, we have to take negative 8, multiply it by 4, and we get negative 32. So the third term is negative 32. Number 12, an infinite series has A1 equal to 6 and a sum of 9. Find R. This is an infinite series. So the formula for that is S equals A1 over 1 minus R. Okay, so we're going to plug in all the things that they gave us. They gave us A1. Oh, they also gave us the S. S equals 9. So let me rewrite that. So 9 is equal to, the A1 is a 6. We're finding R, so they did not give us R. So 1 over 1 minus R. I need to get that R out of the denominator, so I'm going to need to multiply both sides by 1 minus R to get those to cancel. Don't forget though, you got to distribute that 9 to both the 1 and the negative R, so that'll be a 9 minus 9R equals 6. And now we just have to solve for R. So I'm going to subtract 9 from both sides. So negative 9R is equal to negative 3. And then I'm going to divide both sides by negative 9. A negative divided by negative is positive, so this is going to be a positive number, and 3/9 reduces to 1/3. So our common ratio is 1/3. Now we're into the polynomials. Write the cubic polynomial in standard form with roots 2, -4, and 0. So we're talking a cubic. So that means there's going to be an x cubed in there, and that's the highest degree it's going to have. Remember, the degree tells us how many roots, and they gave us 3 of them. And remember, roots also mean the solutions, the x-intercepts, the zeros. Those all mean the same thing. So we're working backwards. We've got x equals 2. We have a root of x equals -4 and a root of x equals 0. And we have to work backwards. We have to figure out what factors did these solutions come from. So if I were to move that 2 back over on the left with the x, it would be a factor of x minus 2. If I were to move that -4 back over with the x, it would be a factor of x plus 4. And x is always just an x, and since it's a monomial, we always put that in the front. Okay, now we have to multiply, but we can only multiply 2 at a time. So I'm going to multiply the first 2 together first, and we'll put that work over here. So when I distribute that x times the x minus 2, I'm going to get x squared minus 2x. And then I'm going to rewrite the x plus 4 next to it, because now we're going to multiply that in and just distribute. X squared times x is x cubed. Oh, there's my x cubed. X squared times 4 is 4x squared. -2x times x is a -2x squared. And -2x times 4 is a -8x. We got to combine like terms with those x squares. We have a positive 4x squared and a -2x squared. So our final answer is going to be x cubed plus 2x squared minus 8x. And that's the polynomial that those solutions came from. Number 14, ooh, my favorite, long division. And like I said in class today, you can use synthetic, but you have to solve this divisor for x, and you would have to subtract 3 and divide by 2, and you'll get -3/2 in your little corner box for synthetic division. So you probably don't want to do that. So you don't have to use fractions at all when we're doing long division. All right, so that's my divisor, so that goes out front. So that's a 2x plus 3 that goes out front. And then in the box is what I'm dividing into. So 6x to the 4th plus 13x to the 3rd minus 6x squared plus 8x minus 3. Okay. All right, so now let's start this off. What do I need to multiply by 2x to get 6x to the 4th? Well, I need a 3x cubed. And then we have to distribute. 3x cubed times 2x is the 6x to the 4th that we planned on. 3x cubed times 3 is a positive 9x cubed. But then we have to subtract. So we're going to change the signs to their opposites. The first term should cancel. 13x cubed minus 9x cubed is 4x cubed. And bring down the next term. Do it all over again. This time we need a 4x cubed. So what do we multiply by 2x to get 4x cubed? I need a 2x squared. 2x squared times 2x is a 4x cubed. 2x squared times 3 is a positive 6x squared. And then I have to subtract. So there's a sign change. Those first terms cancel like they're supposed to. And negative 6x squared minus 6x squared is negative 12x squared. Now, I do need to bring down the next term, but I'm out of room here, so I'm going to rewrite what's left over here. I have a negative 12x squared plus 8x minus 3. And I'll start from here now. So now, what do I multiply by 2x to get negative 12x squared? I need a negative 6x. So negative 6x times 2x is negative 12x squared. Negative 6x times 3 is negative 18x. And then we have to do the sign change because we're subtracting. So it's changed to pluses. These cancel. 8x plus 18x is a 26x. And then bring down that last term and do it one more time. All right. What do we need to multiply by 2x to get 26x? This time it is a positive 13. 13 times 2x is 26x. 13 times 3 is a positive 39, and then we got to do the sign change. Those first terms cancel. Negative 3 minus 39 is negative 42. So we got a remainder. Now when we write our remainder, we write it on the end. It's negative, so put minus. And then 42 over the divisor is a 2x plus 3. So my final answer is this. 3x cubed plus 2x squared minus 6x plus 13 minus 42 over 2x plus 3. That was a mouthful. Number 15, find the roots. This is where you do get to use synthetic division. So on this one, we have to find the PQs. P's over Q's. Remember, the P's are the factors of the constant, and the Q's are the factors of the leading coefficient. So my P is just a negative 2, so factors of negative 2 are just plus or minus 1 and 2. In the denominator, it's just a 1, which is just factors of 1. That's it. So I really don't have a denominator. So my 4 numbers to work with are 1, negative 1, 2, and negative 2, taking care of the plus or minus. So I need to use synthetic division. So I'm going to pick a small number to try. I'm going to try a 1. So these are my list of numbers to try. Now let's use the coefficients of the polynomial. 1, 5, 3, negative 7, negative 2. Oops, I need to give myself some space. All right, and then we always bring down the first number. And then we multiply. 1 times 1 is 1. And then we add. 5 plus 1 is 6. And do it again. 6 times 1 is 6. 3 plus 6 is 9. 9 times 1 is 9. Negative 7 plus 9 is 2. 2 times 1 is 2. Oh, negative 2 plus 2 is 0. That's what we want. We want a 0 remainder because then that tells me that x equals 1 is a solution. So there's one of them. I need a total of 4 because that's the highest degree. There are 4 roots here. Okay, so I got 1. Now, we started with an x to the 4th. We just divided out an x, so this 1 right here represents a 1x cubed. Well, I can't really factor 1x cubed, so I'm going to keep going. So now I have more numbers to try. The next number that's going to work is going to end up being a negative 2, I think. Let me double check. This is number 15. Because I don't have a lot of room to work here, so I don't want to show you my work on trying all the different numbers. Yeah, it's a negative 2. So let's try negative 2 in the box now using our new numbers, 1, 6, 9, 2. You don't put the 0 at the end. If there's a 0 in the middle somewhere, then yeah, but at the end, that was our remainder of 0, okay? And then start the process all over again. Bring down the 1. 1 times negative 2 is negative 2. 6 minus 2 is 4. Do it again. 4 times negative 2 is negative 8. 9 minus 8 is 1. Do it again. 1 times negative 2 is negative 2. Oh! And that adds up to 0. So there it is, but I told you that it was going to work. So I can't draw a circle today. X equals negative 2, or an oval. All right, I've got 2 of the roots. I need 2 more. So it started as an x to the 4th. We divided out an x. That becomes an x cubed. We divided out an x again, so now this is an x squared. So this is really a 1x squared plus 4x plus 1. That's not factorable because the product is 1 and the sum is 4. 1 times 1 is 1 and 1 plus 1 is 2. There's no way we're going to get a 4 out of that. So we have to go to the quadratic formula. So I always tell my students, and we'll put the work down here on the side right here. I always tell my Math 2 students to identify the ABCs. A is 1, B is 4, C is 1. AX squared plus BX plus C, you know, standard form of a quadratic. And then we're going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is 1. Sorry, I have someone at my door. All right, I hope that saved my first video, but someone came to the door to turn in late work and didn't care that I was recording. So yeah, there we go. Anyways, here we go. I'm a little irritated. So negative 4 plus or minus the square root of 4 squared is 16 minus 4 times 1 times 1. So 16 minus 4 is 12, all over 2. We have to reduce that 12. There's a hidden perfect square inside of it. 4 times 3. 4 is the perfect square. So I always tell my Math 2 students to circle the perfect square because we could take its square root. The square root of 4 is 2, so that gets to come out. Then you're done with that 4. The 3, though, is not a perfect square. It's stuck inside, all over 2. And then I also tell my Math 2 students that if these 3 numbers have something in common, then you can reduce them. But it's all or nothing. And in this case, all 3 numbers do have something that we can reduce out. A 2. 2 divided by 2 is 1. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. So we get negative 2 plus or minus the square root of 3 all over, oops, the 2 canceled out to a 1, so I don't have anything in the denominator. So this is my final answer. But in Edulastic, which you might see if you get to this problem in Edulastic online, it's going to have you type in the decimal form of the answer. This plus or minus gives us the 2 remaining roots that we were looking for. So let's actually find those last 2 roots. I'm going to get x equals, I'm going to need to type in my calculator, negative 2 plus the square root of 3. And then the other one I need to type in my calculator is negative 2 minus the square root of 3. The plus and the minus. Okay. We are going to get decimals for these. Okay. So negative 2 plus the square root of 3. Oops, not plus. Equals negative 0.27. So there's my third root. And then negative 2 minus the square root of 3 is negative 3.73. Okay. So there's that, and that was number 15. So let me highlight my solutions. I had 4 solutions, my 4 roots. Here's 1, here's 2, here's 3, and here's the 4th one. So those are all 4 roots. Look at all that work. Yep. Number 16, use the remainder theorem to determine which of the following binomials are factors of p of x equals x cubed plus x squared minus 10x plus 8. Select all that apply. So because of the select all, this is not your typical multiple choice problem. There's more than one correct answer. And I actually know right now without doing anything how many I'm going to select because the degree is 3. That means that there's 3 roots, so there's going to be 3 factors. So we're going to select 3. Okay, I still have to do the PQ thing on this one. So my P is 8, my Q is 1 again, so I don't really have a denominator, so that's nice. So factors of 8 are plus or minus 1, 2, 4, and 8. Those are all the numbers that can divide into 8. You always have to include itself. So those are our list of numbers to try. It's a little bit bigger of a list than the first problem that we did, the last one we did, but still, start with a 1 or a negative 1. Let's try 1. So we're going to put a 1 in the corner box. And then we're going to write down all the coefficients. We've got 1, 1, negative 10, and 8. Now this is a smaller polynomial than the one from the last problem. Keep that in mind. Bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 10 plus 2 is negative 8. Negative 8 times 1 is negative 8. Oh, we get the 0. So x equals 1 is a root. So in factored form, that would be x minus 1. So that means B is one of the answers. 1 out of the 3. Now, look at what we just did. It started off x cubed. We divided out an x. Now it's x squared. We can factor in x squared or use the quadratic formula. X squared plus 2x minus 8. I believe this is factorable. The product is negative 8. The sum is a 2. Well, 4 times 2 is 8. I need it to be a negative 8, so one of these numbers has to be negative, and since it needs to add up to a positive 2, the 2 needs to be negative because 4 minus 2 is 2. 4 times negative 2 is 8. And these are my remaining factors, so I'm done. So D was one of them, and C was one of them. So B, C, D. Oh, not D. That's an X minus 4. F. B, C, F. My bad. Oh my gosh, I even wrote it plus 4 and still circled the minus 4. So you guys aren't the only ones that do that. I do it too. That's why it's important to show your work. Sometimes we have a brain fart, like it's a real thing. Okay, next says fill in the blanks for the graph below. All right, let's look at this graph first. I notice that the end behavior are going in opposite directions. So this is the equation of the graph has an odd degree. Now, I recognize this graph, and you should too. It is a cubic. It is an x cubed. But the parent function cubic faces this way. So since it's up on the left and down on the right, instead of down on the left, up on the right, it's the reverse. That means that this one must have a leading coefficient that is negative. And now about the roots. However many times it crosses the x-axis are its solutions, its roots. Well, this only crosses through one time, so that means it has one real root. But because it's a cubic, it should have a total of 3 roots, which means that the other 2 roots, oh, it needs to focus. Come on. It means the other 2 roots must be then imaginary. So the graph has 2 imaginary roots, because 2 plus 1 add up to 3. And it makes sense because imaginary numbers, the i's always come in pairs. Everyone has 2 i's, theoretically. Gotta throw that in there. All right, next page, which is the last page. We're almost there, which is good because I have 8 minutes left before lunch. Number 18, find the inverse of each function. So we have f of x equals x squared plus 4. So let's see. We need to Freaky Friday these, just like we did on the first page, but each one of these we can use the shortcut on, okay? But I'm gonna show you both. I'm gonna do the long way first. So change f of x to a y. So get y equals x squared plus 4, and then Freaky Friday! So x equals y squared plus 4, and then we need to solve for y. We always solve for y. So I gotta subtract 4. So I'm gonna get x minus 4 equals y squared. And then I gotta, undo the square. So I gotta square root both sides. I'm gonna flip this around. So y equals the square root of x minus 4, and that's the inverse function. Another way to think about it is to just switch the vertical and horizontal shift. This function is x squared. Its opposite is a square root. Its inverse is a square root. So it should have a square root of x in there somewhere. Okay. That plus 4 means it went up 4. It doesn't have a horizontal shift. Okay. So on the inverse, it's going to have the square root in there. I have to switch the horizontal and vertical. So I'm switching the vertical out and I'm making it horizontal, and it has to be a positive move. A positive move horizontally would be to the right, so x minus 4. And it doesn't have a vertical shift, so that's it. Oh, hey, there it is. Same thing, right? So you can use the shortcut if the shortcut works for you. If not, Freaky Friday works as well, and it doesn't take that long. Here's a cube root, and the inverse of a cube root is something that is cubed, so it should have something raised to the 3rd power in there. And we're also going to switch these horizontal and vertical shifts. This is to the right 1 unit and up 3 units. Those are both positive moves, so when we switch them, they're going to also be positive moves, but switched. Okay, so for the inverse, using the shortcut, I'm going to have parentheses, because it's cubed, x, and now I'm switching the one with the 3. Has to be a positive move, so x minus 3, because going to the right is a positive move. And then up 1, so plus 1. Okay. I didn't do Freaky Friday on this one, but that's okay. I'll do Freaky Friday on the last one. We have to remember, though, the 1/2 power means square root. So let's rewrite this first. So f of x equals the square root of x minus 1 plus 2. This is still the original function. I have not found its inverse yet. The inverse of a square root is something that is squared, okay? So, but I'm going to use the regular Freaky Friday method. So change f of x to a y, right? And then Freaky Friday, change out the x and the y, or switch them out. So x equals square root y minus 1 plus 2. And then we've got to solve for y. So first I need to subtract 2 from both sides. So x minus 2 equals the square root of y minus 1. Then I need to undo the square root. So I have to square both sides. Don't forget to put parentheses around the x minus 2. And you can keep it as x minus 2 quantity squared. The y minus 1 gets to come out. And then we just have to add the 1 over. So when I flip it around, I'm going to get y equals x minus 2 quantity squared plus 1. And that's the inverse function. And you can rewrite it again and put f inverse of x instead of the y, or you can keep the y, it doesn't matter. For the shortcut version, you would just switch the 1 and the 2, but you have to remember that a square root changes, or its inverse is something that is squared. And look, the 2 and the 1 switch. 1 and 2 switch. So the 2 is in the parentheses and the 1 is outside the parentheses. And that's what we got. Okay, so you can use a shortcut if you know it, or Freaky Friday, and it's still not that bad, so there you go. Number 19, we're going to solve this cubed root function, and so here we go. We got to isolate the cube root, so we got to add 5 to both sides. Cubed root of x minus 2 equals 2. Now we got to undo the cube root, so we have to cube both sides. So x minus 2 gets to come out. 2 times 2 times 2 is 8. Add 2 to both sides, and x equals 10. We don't need to check it because cube roots don't get extraneous solutions. And there we have it. I hope this helps you guys. Have a good one.